This is section 4.1. We are graphing equations in slope-intercept form. Chapter 4 is all about slope-intercept form. You guys will know that form inside and outside, forwards and backwards, when you're finished. Have you worked with slope-intercept form before? You guys probably have. What about Brett? No? Okay. No big deal. If you haven't, we will use it enough. You will be very familiar. When I say slope-intercept form, first of all, it's called slope-intercept form because this equation is going to give you a slope and it's going to give you a y-intercept. Everything we need to graph. Y equals mx plus b. When I say slope-intercept form, that's what I'm referring to. Y equals mx plus b. You will know this very, very well. There's lots of different ways you can graph. I want you guys to know one way really, really good, and this is the way that I'm going to teach you to graph, and it's with slope-intercept form. In slope-intercept form, we have, like I said, a slope, and we have a y-intercept. M, that's the variable that stands for our slope. And B, the y-intercept, so once again, if we have an equation that's written in slope-intercept form, we're going to know the slope and we're going to know the y-intercept. Likewise, if we want to write an equation in slope-intercept form, we're going to have to know what our slope and what our y-intercept are. That's why it's called slope-intercept form, because it gives you both of those values, or you need both of those values to use it. Okay, so let's look at this first example. It says to write an equation in slope-intercept form of the line with slope of 1/4 and y-intercept of -1. Then graph the equation. They want us to write an equation in slope-intercept form. That's y equals mx plus b form. In order to write an equation in this form, we're going to have to know our slope and we're going to have to know the y-intercept. That's just what you have to have. You have to have those two items to write your equation. In our problem, they gave us the slope. What did they tell us that value was? 1/4. So I know m is 1/4. And b, they gave us the y-intercept. That's -1. So now that we know our slope and we know what our y-intercept is, we can write our equation. Y equals 1/4 x minus 1. To write my equation, I took 1/4 and I substituted in for m, my slope, and I took my y-intercept of -1 and I substituted in for the y-intercept, b. Now that we have our equation in slope-intercept form, y equals 1/4 x minus 1, it's in a form that's easy to graph. In order to graph, we're always going to start with our y-intercept. Our y-intercept is at -1. So I want you to take your pencil and put a dot at -1 on the y-axis. This will happen because there's already a dot there. Okay, so from that point, we're going to use our slope to help us find additional points along our line. If you remember back to chapter 3, slope, m, is rise over run. It's rise over run. So to find points, we're going to rise and run from -1. My rise is +1, so I'm going to go up 1 unit. My run is +4, so I'm going to go right 4. 1, 2, 3, 4, and put a dot. I'm going to do it again. I'm going to go up 1, and I'm going to go right 4. Even though it's off my graph, go ahead and estimate approximately where that point would be. Now, instead of rising 1 and running 4, we have another option. We could have went the other direction.
Couldn't you go down 1 and go over 4?
You got it. That's right. We could have. Isn't -1 divided by -4 the same as +1/4? -1 divided by -4 is the same as a +1/4. So I could have went down 1. My rise is negative. I'll fall 1. And then I'm going to go left 1, 2, 3, 4. Take care of negative 4. That would be my new point. I need you to have a minimum of 3 points on your graph. A minimum of 3. You can have as many as you want, but a minimum of 3. So take your straight edge. Let's draw a line through the points. Make sure you extend it past those dots, the last points, and put arrows on the ends. I want the arrows to show that that graph does continue on in both directions. Okay, so just to reiterate, we wanted to find the equation of our line, and we wanted to graph the line. Look at this next example. Write an equation in slope-intercept form of the line whose slope is 4 and whose y-intercept is 3. All right, if we want to write an equation, we're going to need to know our slope, m, and our y-intercept, b. And this probably do give us the slope, and they do give us the y-intercept. What is the slope? 4. And what is the y-intercept? 3. So we know m and we know b. Let's put it into our equation. Y equals 4x plus 3. And sometimes it helps to write y equals mx plus b until you get the hang of it and you're very familiar with that equation. We're going to put 4 in for m and 3 in for b. So the correct answer here would be letter B. I do want you to take this a step further. Let's go ahead and graph this equation. The y-intercept is at 3, so let's put a dot at 3 on our y-axis. The slope is 4. Now, our slope is not currently written as a fraction, but you can make any number a fraction by putting it over 1, can't you? So I'm going to make that 4 over 1. So let's plot negative 4 over negative 1 now. We're going to go down 4, 1, 2, 3, 4, and left 1. 1, 2, 3, 4, and left 1. Just a reminder, you need a minimum of 3 points. So as many as you need, but a minimum of 3. A step further now. I'm going to give you an equation. It's not necessarily going to be in slope-intercept form. 5x plus 4y equals 8. I want you to graph this equation. We are practicing using slope-intercept form, so I want you to put this equation into slope-intercept form. If you think back about, I think it was chapter 2, when we were solving equations, we did literal equations where we had lots of variables and we solved for a specific variable. That's essentially what we're doing. We're trying to get y by itself. So in this equation, to get y by itself, I would subtract 5x. We have 4y equals negative 5x plus 8. Go ahead and solve for y. We'll divide every term by 4. So y equals negative 5 force x plus 2. So what is the slope of this equation? Negative 5 over 4. What is the b, the y-intercept? 2. Okay, now that our equation's in slope-intercept form, we know our slope, we know our y-intercept, we can graph this equation. So let's put a dot at 2 on our y-axis. Okay, so we're going to use our slope to find additional points. Remember, slope is found by using rise over run. So from this point, we're going to go down 5. 1, 2, 3, 4, 5. And we're going to run as a positive force. We're going to go 1, 2, 3, 4. Let's go down 5. 1, 2, 3, 4, 5 and run 4. Take your straight edge and draw your alignment. Move those arrows on the ends of your line. Let's try this one. Once again, I need to put it in slope-intercept form so it's easy to graph. What would you guys do first to put this into slope-intercept form? Damien.
Subtract 3x.
Good, subtract 3x. So we have 2y equals negative 3x plus 6. Devin, what would you do next?
Divide by 2.
Very good, divide by 2. Now remember, we're dividing each term by 2. So I have negative 3 divided by 2, I'm going to leave that as a fraction. X plus 6 divided by 2, I can simplify, so I'm going to. It's 3. So what is the slope of this equation? Negative 3 over 2. And Rachel, what is the y-intercept? 3. We know our equation is in slope-intercept form. We know the slope, we know the y-intercept. We can graph. When you graph, you always begin with your y-intercept, the b. So our y-intercept is 3. Let's put a dot at 3 on the y-axis. Ignore this other dot that's there. Just came from another graph. Y-intercept is 3. If you think about your slope, that is rise over run. Our rise is negative, so that means I'm going to go down 3. 1, 2, 3, and run a positive 2. Down 3, and run 2. Down 3, and run 2. So let's graph x equals negative 7. This doesn't look like the other equation because we don't have a y variable. We can still graph this equation, not necessarily using slope-intercept form, but instead a t-chart. So let's make a t-chart. In our t-chart, every time x is going to have to equal negative 7. We don't have an option for x other than negative 7. So whatever we put in for x has got to be negative 7. Y could be anything. Y could be 0. But x always has to be negative 7. So let's go ahead and plot these points. So negative 7. 0. So it's going to be a vertical line. So a vertical line with all of our x coordinates being negative 7. Let's try one that looks like this. 5y equals 10. Okay, for this example, let's go ahead and solve for y. Divide both sides by 5. Put it in slope-intercept form. Y equals 2. Now it looks different than we're used to seeing for slope-intercept form because we don't have x. That's okay, we can still graph this. Let's use a t-chart to help us graph. This time in our t-chart, the y value is always going to be 2. I can put whatever I want in for x but y is always going to be 2. So let's plot these points. Straight edge and drawing a line in. This example says, which of the following is an equation in slope-intercept form for the line shown in the graph? So we're going to go the opposite direction. I'm going to give you the graph and ask you to write the equation. So in order to write an equation in slope-intercept form, what are the two things that we have to have? Well, we need to know our slope, we need to rise over run, and what is the other value we need to know in order to graph, or to write the equation? The y-intercept, the b. Let's look at our graph here. Where does our graph cross the y-axis at? 0, -3. So our y-intercept b is -3. We can find our slope by picking another point. That's a good point. And now we can use rise over run to find our slope. We're going to go up 2, so the rise is 2. And we're going to go to the right 1, the run is 1. 2 divided by 1 is 2. So our equation should be y equals 2x minus 3, which is letter B. Alright, so today we practiced writing equations. If I gave you a slope and a y-intercept, we should be able to write the equation in slope-intercept form. We should be able to graph equations in slope-intercept form. And we should be able to write an equation if I gave you a graph. Pick out the slope and pick out the intercept. I do have some problems for you to practice. They're going to be out of your textbook. The assignment is on the top of the graph paper.